Good morning, grade 11s. So this is your last actual recorded lesson on the urinary system. However, that being said, I will give you 3 lessons to do it. So this is called lesson 8, but you will have 3 lessons to actually do the work for lesson 8, and then you will have a 4th lesson to check your answers for the activities at the end of lesson 8. And that lesson will be next week, Friday, the 29th for choice 1, and the following week, Monday, for choice 2. All right, but I'm sure that you can work out the dates. We'll go through that again at the end of this. Okay, so first of all, just maintenance of the pH of the blood by the kidney, which I know that I did speak about when we did the animation and just before the animation last lesson. So the pH of the blood varies between about 7.35 to 7.45, which means very slightly alkaline. Because remember that 7 is neutral. Anything above 7 is alkaline, anything below 7 is acidic. So it's a very slight alkaline. And remember that it's important that the pH of the body remains within the optimum levels, because if it doesn't, then the enzymes that catalyze all the chemical reactions of metabolism can't function effectively. So while when we did nutrition, the different parts of the digestive system, those enzymes had a wide range of pH at which they work best, depending on where the enzyme is situated. It's not the same for the rest of the body. For the rest of the body, optimum pH, slightly alkaline. And so, if the pH of the blood drops, in other words, it becomes more acidic, then what the body does is it secretes hydrogen ions from the blood into the filtrate, and those hydrogen ions then become part of the urine and they pass out of the body, and that raises the pH of the blood. Now, for those of you who are non-science students, a measure of an acid is the fact that it releases hydrogen ions and how many hydrogen ions it releases. So I'm sure that you all know that all of the acids contain hydrogen, so it's things like hydrochloric acid, hydrogen sulfide, all that. No, sulfuric acid, that's what I wanted to say. They all contain hydrogen. And so if hydrogen ions pass out of the body in urine, then the pH of the blood rises. Okay. If the pH of the blood rises above the norm, above the 7.45, then fewer hydrogen ions and more bicarbonate ions are secreted from the blood into the filtrate. And bicarbonate ions are alkaline, and that raises the pH, drops the pH of the blood. Okay, all right, so this just shows you the different parts of urine. 95% of urine is water. Then there is a little bit, 0.2%, don't obsess, is creatinine, ammonia, and uric acid. And if you remember when I started this section, I said to you that one of the main reasons why the kidney does what it does is to get rid of nitrogenous waste substances. And I explained that when the proteins that are taken in during digestion are digested down to amino acids and get absorbed, amino acids are good too many amino acids are toxic. And so the blood passing through the liver is monitored by the liver. And if there are too many amino acids, the liver removes the amino group from the excess amino acids and converts the amino group to ammonia or uric acid or urea. And I said to you that mammals mainly excrete their nitrogenous waste as urea. So a little bit of ammonia, a little bit of uric acid, mostly urea, 2% of this urine is urea. And then 2.8% dissolved salts and other ions. You don't have to obsess about that. Okay, mostly water. So urine passes out of the collecting ducts, or the ducts of Bellini, into the calyx, and then into the pelvis. It leaves the kidney via the ureter and passes to the bladder, where it is stored until urination. Urine passes from the bladder to the exterior through the urethra. So today we're going to talk mainly about kidney disease. So chronic kidney disease is the most common form of kidney disease. So remember that the word chronic doesn't mean bad, as many people use it to mean. It means long-term, and it doesn't improve over time. So chronic kidney disease is a long-term condition that doesn't improve over time, and it's commonly caused by high blood pressure. And what happens is high blood pressure increases the pressure in the glomeruli. And over time, it causes the tiny little capillaries in the glomeruli to burst. And because of that, the glomeruli no longer function as filters. Blood just flows through. And it's not on the basis of size. So kidney function will eventually deteriorate to the point where the kidneys can no longer perform their job properly. And at that point, a person would need to go on to dialysis. Now, there are a number of different ways in which dialysis is done, and we're not going to focus on those. We're simply going to talk about simple dialysis using a dialysis machine that filters the blood. So what dialysis is able to do is to filter the extra fluid in the body and the waste out of the blood. It can help to treat the kidney disease. It can't cure it. It really just functions as an external kidney. Another option in a case like this might be a kidney transplant, depending on the circumstances. But it's very difficult to get a donor kidney, and specifically a donor kidney that matches a person who needs a kidney. Then, and this is a huge issue in South Africa, because there are a myriad of people who suffer from diabetes, especially diabetes type 2. And so diabetes is also a major cause of chronic kidney disease. What happens with diabetes is that a person is unable to regulate the blood sugar level in untreated diabetes, that is. And so the increased level of sugar in the blood damages the blood vessels in the kidney over time. And therefore, the kidneys can't clean the blood properly, and kidney failure can occur when the body becomes overloaded with toxins because the kidneys haven't been able to do their function. So we're going to talk about kidney dialysis as being hemodialysis. There is another kind, another very important kind. We're not going to talk about that. Okay. So what happens is in hemodialysis, the normal method of dialysis, the most common one, a needle and a tube is inserted into a blood vessel, normally in the arm. It doesn't always have to be in the arm, especially if a person has long-term hemodialysis and the blood vessels in the arm become damaged. Then that little port into one of the blood vessels in the neck. So the blood then flows out of that blood vessel through the needle, through the tube, and into an external machine that filters it, just like a kidney does. And then it passes back through a different tube and a different needle into a vein in the body, and it has been filtered. Now, a person who goes for dialysis would then have to go to a dialysis center, normally 3 days a week, with each session lasting around 4 hours. So you can imagine that it actually is very intrusive on a person's normal lifestyle, that they have to spend so much time in hospital being attached to a machine. So this just shows you one example of a hemodialysis machine. Hemo because it's filtering blood. So what is happening here is, and I'm not sure which one's which here, one of these blood vessels is blood leaving the body, and it's going through the machine, and it's being filtered in the machine, and then it's being pushed back into the body through one of these little tubes here. And so what the machine is doing is it's acting as a filter, just as a kidney would. Okay, so complete the homework activity on page 262 of the textbook. I thought I'd put in a thing of the dialysis machine, but I obviously haven't. Okay, so make sure that you have a look at that in the textbook and you know how this works. You don't have to, yes, there's a drawing on page 260 of the textbook. You don't have to obsessively know about how a dialysis machine works, but just know that it's like an external kidney and that it takes a lot of time out of a person's life to go and have it done. It's also not as effective as a normal kidney. All right, let's talk about kidney transplants. A kidney transplant is a surgical procedure, and it places a healthy kidney from a living donor or a deceased donor into a person whose kidneys no longer function properly. So because every individual has 2 kidneys, or maybe 3. I taught a student once who had 3 kidneys. One was quite tiny and didn't work that effectively, but she did have 3 kidneys. Anyway, that was a little sidetrack. Okay, so every person has 2 kidneys, and it's possible to function with just 1 kidney. And so it is possible that if a person needs, let's say person A needs a kidney transplant because neither of their kidneys work, if person B is compatible, in other words, suitable as a donor, then person B can donate 1 kidney out of person B's 2 kidneys to person A, who doesn't have any functioning kidneys. So that would be a living donor. And very often a living donor is a person who's related. So 2 siblings, for example, one might donate a kidney to the other sibling if they are compatible. And just because they're siblings doesn't necessarily mean that they are compatible in terms of transplanting of organs. So the blood vessels in the new kidney are attached to the blood vessels in the lower part of the abdomen, just above one of the legs. And if you look here at the drawing, there's the little donor kidney. Generally speaking, unless there are complications, they will leave the other 2 kidneys, even though they're non-functional, in position. And here what they've done is look at the donor kidney. They've attached the donor kidney to the iliac artery, in other words, just above where, just below where it branches off down to the leg, off of the abdomen, aorta. And here they've attached the vein to this major blood vessel here. And then there's the ureter from the donor kidney is just attached directly to the bladder. Okay, so this then should function as a normal kidney. Okay. So what are the advantages of a kidney transplant over kidney dialysis, hemodialysis? Generally speaking, a much better quality of life. Because remember, a person who's having hemodialysis has to be close to a center where they can go 3 times a week to go and have kidney dialysis, and it's very time consuming. It's also not ideal. I know when I was in hospital for an operation once, there was a girl in the bed opposite me who was a dialysis patient, and she was having complications where the little port that they'd inserted in her neck, because her blood vessels in her arms were not of good quality, that little port kept on closing and becoming septic. So not ideal. All right. Lower risk of death, fewer dietary restrictions. It's when a person's on hemodialysis, there are all sorts of things that they're not allowed to eat. They're not allowed to have much salt, etc., etc. Obviously, much lower treatment cost, because not having hemodialysis 3 times a week means much lower medical charges. And then obviously only 1 donated kidney is needed to replace 2 failed kidneys, making living donor kidney transplantation an option. However, any factor that could affect the ability to safely undergo the procedure and to take the medications needed after a transplant to prevent organ rejection must be taken into account. Now remember that if a person has any kind of transplanted organ, for the rest of their lives, they have to take medication to prevent organ rejection. It's not you have a transplant and you're healthy and you're wonderful and you never take meds again. It's anti-rejection drugs for forever. Okay. Kidney stones. These are another common kidney problem. And what happens is when minerals and other substances in the blood crystallize in the kidney, so instead of being dissolved in the fluids in the kidney, they become crystals in the kidneys, and then they form solid masses called stones. Kidney stones usually pass out of the body during urination, but it's really painful apparently to pass them. And normally they don't cause significant problems. So let's look at the X-ray. Here on this X-ray, you can see 2 kidneys, 2 stones, kidney stones in this person's body. This kidney in longitudinal section, that's a kidney stone. This entire thing is a kidney stone. And there's another little one there. And I think there's some little ones here as well. So you can see that this entire renal pelvis has been blocked by means of a kidney stone. Now, at that point, they normally need to do surgery. If the kidney stones are not too big, but are not passing naturally, what they do is they use, I think it's sonar, not certain, to vibrate the little kidney stones, and that breaks them up into smaller pieces, and then they're more likely to pass out. Okay. Right, now this is your work for the next 3 days. Today and the next 2 days, sorry. Complete the questions on excretion in humans on pages 267, 268, 269 of the textbook. And then don't forget to go back and look at the diagram of dialysis on page 260 of the textbook. And that's the end of excretion. So if you've got any questions, don't forget to ask Mrs. Florenza or me, and we are very happy to answer them.